Never has the need for safe, efficient electrical energy been greater than it is today. Our world is undergoing the largest wave of urban growth in history. With the prevalence of urban sprawl and cities becoming more densely populated, electrical energy has to be distributed safely and efficiently with the least amount of environmental impact. With that end in mind, cast resin transformers are deployed as part of the electrical distribution system. Since the onset of the millennium, nowhere have the trends of urban growth and expansion been more prevalent than in China. This massive expansion, coupled with the ever-increasing demand for electrical energy, has led to closer proximity of power distribution equipment to the points of consumption, further leading China to require the deployment of cast resin transformers in all buildings with public access, making this the largest market worldwide for cast resin transformers. There is one company who has served as a leader in the world's largest market and has emerged as a premier supplier in a unique position to supply the global demand for cast resin transformers. That company is JST. Designed for value, engineered for quality, built to last. Our quality is initiated with the first stages of design. Calculations are triple-checked and user specifications are read line by line to assure compliance and conformity with local codes. We feel the practice of getting it right the first time is best for all. Both our high voltage and low voltage coils are solidly casted in pure epoxy resin, and these windings are rigidly bound by a fiberglass mat to add unmatched strength. This construction ensures exceptional strength to guard against any short-circuit mechanical forces that always are possible. The voltage-withstanding strength of our insulation system can reach levels of up to 200,000 volts. Every part of the coil winding is protected against moisture or harsh environmental components to assure proper function, and therefore can be started up in a moment's notice without the usual pre-drying time needed for VPI construction. JST's enclosures are unmatched and unparalleled in the industry. Our tank-like construction assures safety and proper protection. Each unit is custom built according to protection class, size restrictions, and cooling requirements. From our standard NEMA 1 indoor enclosures to our NEMA 4X stainless steel construction, we design what is needed for the project. Whether it is step up or step down, distribution or substation, the application is incorporated into the design. JST has supplied transformers for some of the most common or even classified applications. In the heart of the city or the remote desert, there is a JST transformer running 24/7 with minimal maintenance. Some of our applications include data centers, colleges, new buildings, power plants, or even water-cooled applications. Engineering excellence has been the cornerstone of JST's success in becoming one of the world's largest suppliers of transformers. The latest sophistication in software tools are used to promise accuracy. We invest heavily in our engineering talent to assure our years of dedication to product development are passed down to the next generation. These steps have enabled JST to create a platform to service customers more accurately and efficiently. Whether it is ANSI, IEEE, IEC, or even JEC, our engineering staff is fluidly versed in the worldwide specifications in transformer design. It starts with our quoting department, dissecting the customer's supplied specs or coordination drawings, and the result is an accurate design. JST has developed an electromagnetic design system that utilizes an extensive database to create models based on current requirements. Designs are generated rapidly and providing an exact match to our customers' needs. JST's advanced design methodology is supported by a world-class manufacturing process that is vertically integrated, highly automated, and extremely flexible. Attributes which all promote an extremely high level of manufacturing efficiency and control, with no sacrifice to JST's ability to customize. JST believes in proactively managing lead times, resulting in a vertically integrated manufacturing process as exemplified by the metal fab and finishing line for fabricating enclosure panels, or our wire drawing line which produces the insulated wire used to produce our coils. Time is a critical resource for our customers as well as our employees, and this thought influences every aspect of JST's manufacturing process. That is why a high level of sophistication is built into JST inventory management. Through the use of barcodes and other controls, JST is better able to reduce lead times and achieve more accurate scheduling. Nothing but the strictest adherence to material specifications suffices for the raw materials utilized in the JST manufacturing process. Material selection is a key component to building a quality product. JST's engineers are diligent in their selection of raw materials and carefully qualify these for use in manufacturing. Often, the material specifications will dictate that certain materials are imported, which is why JST has set up an international purchasing organization at their Carlstadt, New Jersey facility. The strict controls applied to raw material selection are complemented by equally stringent controls when processing the materials. JST uses only the highest purity extrusions to fabricate the wire used in coil winding. In turn, the wire is wrapped with a special grade of insulating material that will ensure a void-free casting. Imperfections are not tolerated as a possible outcome in either the wire fabrication or wrapping process, and the appropriate controls are put in place to ensure these results. These controls are but a few in a sea of many when it comes to JST manufacturing process. HV coil winding is performed by highly trained craftspeople equipped with machinery that provides continuity in the control of processes to achieve perfection. The same diligence goes into LV coil winding with respect to using highly skilled operators and strict controls to wind the foil layers and making the final weld to the terminals. JST has perfected a process that employs the use of thin wall molds utilized during the epoxy casting operation. Benefits include better manufacturing throughput as well as a highly uniform casting. The coils fitted to these molds are ready to undergo the vacuum casting process, which is at the heart of coil fabrication. The molds are placed in vacuum casting chamber, which utilizes an oil diffusion pump to create the necessary vacuum to ensure a void-free casting. Sophisticated controls monitor all critical parameters for this process, so achieving a perfect casting is not left to chance. One element of the process unique to coils casted at JST is the method used to mix the epoxy resin and the hardener. Most common to the industry is a method called dynamic mixing, which basically batch mixes both parts prior to injection into the molds. In the interest of more uniform curing and producing a casting with a higher degree of integrity, JST has chosen a superior static mixing process. Both parts are mixed in the injection head as they are being poured into the molds. While the equipment deployed to do this is more costly, the benefits realized are another way JST provides more value to customers. Any voids or cracks in the insulation system are detected during partial discharge testing. We do this to ensure a completely uniform solid cast system with absolutely no inconsistencies or defects. Our detection system qualifies a unit only below 10 picocoulombs, which is 1/1,000,000th of a coulomb. It is only fitting that such rigorous design and material selection be supported by equally rigorous manufacturing methods with the appropriate controls to ensure product quality. When we look at how JST minimizes noise, reduces losses, and realizes high efficiencies, we can start by looking at how the transformer's core is fabricated. By design, the core geometry uses a step-lapped, mitered construction with low-loss core steel as the selected material. As previously mentioned, vertical integration is at the heart of the matter when it comes to the ability of JST to control their own destiny with respect to flexibility in design, lead times, and meeting performance requirements. It is for this reason JST utilizes core steel supplied directly from the mills, which undergo an advanced slitting process. This slitting process cuts the steel into strips with strict control on the strip width and tension as the strips are spooled to be used in fabricating the core laminates. Precision stamping equipment is used to cut the core laminates. The process for cutting the laminates of the core legs is highly automated and under computer control. The core cutting machine selects the correct core width and then cuts a series of laminates, each stepped in length, before automatically selecting the next strip width to achieve the desired cylindrical cross-sectional geometry of the core leg. Each laminate is automatically stacked on a stacking table during this process. The end result is a core leg held within the strict tolerances to achieve the desired core geometry. The cores are then assembled into a trident structure with a protective finish applied. Careful inspection of each assembly is typical of every JST subassembly used in the final transformer product. It is this attention to detail that enables JST to achieve a level of quality unsurpassed by others. JST has set up an extremely efficient assembly line for marrying coils to cores. Fully equipped work bays are linked by a rail system, with a mobile carrier achieving a high degree of factory mobility and significantly reducing the time needed for moving heavy objects from station to station. Better factory throughput and a flexible manufacturing line yields better lead times without sacrificing any desired customization. Transformer enclosures are frequently the items which require the greatest degree of customization, and the metal fabrication line at JST is more than up to the challenge. With some of the most modern CNC equipment available in place at the factory, the possibilities for custom enclosure designs remains limitless. Enclosure panels are superbly finished with a powder paint coating, achieving a tough, durable finish second to none. Final assembly is where everything comes together, and there are no shortage of the right equipment and skilled production staff applied to these very important final stages of manufacturing. Final assembly is approached with the same level of diligence as every component as to ensure a consistent, dependable quality in every facet of the operation. Advanced test facilities at JST confirm the strict adherence to the intended requirements and verify that the transformers are ready to ship. JST products are thoroughly tested to the prescribed set of tests as specified by the applicable industry standards or custom test programs, uniquely defined by the customer's specification. In-house capabilities are present for both design and routine tests, regardless of the applied industry standards, which is dependent on region. JST understands the regional differences around the world and can adapt to the appropriate standards. One of the greatest attributes of cast resin transformers is the ability for the transformer to withstand the harshest environments. JST leaves nothing to chance in qualifying their transformers for these harsh environments and has set up in-house capabilities to stimulate and test the extremes of these demanding environments. Transformers are subjected to extremes in temperature, humidity, and corrosive atmospheres, and tested for their ability to withstand those extremes. From the initial inquiry through fulfillment, JST is committed to excellence in providing a high-quality product delivered on time. As a part of the commitment to excellence, JST ensures fulfillment with minimal impact on the environment, which is a core element of JST's management philosophy. Guided by this commitment, and as a member of the international community, JST achieved internationally recognized certification for quality, safety, and environmental impact. Further evidence of JST's commitment to the environment is seen by the voluntary investments made in plant equipment, allowing JST to manufacture an environmentally sound product in an environmentally sound fashion. This 2 megawatt solar power generating station was developed by JST during the Coil expansion project and enables JST to reduce their carbon footprint while expanding production capacity to meet the ever-increasing demands for JST products. Waste and water treatment systems are put in place, helping to preserve precious resources and leaving the environment free of contaminants. With cast resin transformers supplied on a global basis, JST also expanded operations to address the needs of the international community. The 25,000 square foot facility in Carlstadt, New Jersey was opened in November of 2009 and functions as a service hub for the Americas and Europe, as well as a corporate office. The friendly Carlstadt, New Jersey staff is ready to provide assistance from initial inquiry through after-sales service and at all points in between. Applications engineering is available to help customers formulate their design goals and answer technical questions. The customer service team is equipped to handle quoting, order entry, up-to-date order status inquiries, and expediting if necessary. Project management facilitates the submission of technical documentation, such as approval drawings, as well as field coordination to assist with installation and commissioning. Product assembly capabilities are in place at the Carlstadt, New Jersey facility, as in some cases customers desire their products to be assembled and tested there or require some level of integration of either their own equipment or that of another manufacturer. Warehousing is available in some cases to help customers weather an erratic project schedule. Owing to the positive attributes of cast resin transformers, their use is slated for a variety of applications. Data centers need high reliability and efficiency and leave no room for the possibility of contamination. Immunity against dust and the ability to handle additional harmonic loading make cast resin well suited for subway systems or similar harsh environments, such as may be found in processing plants. Environmental concerns promote alternative forms of energy, such as wind, and it is only fitting that an environmentally friendly transformer, such as cast, be used in these applications. The positive effect on the environment also makes the use of cast attractive in buildings of college campuses and high-rise buildings in densely populated areas. JST transformers find their homes in installations throughout the world. New York's World Trade Center, subway systems in Chicago, LA, New Orleans, Nanjing, and Shenzhen, New York's LaGuardia Airport and Shanghai's International Airport, data centers in Virginia and New Jersey, over 30 wind farms, with 4 in USA and Canada, more than 20 in Europe, and 1 in Australia. As our world tends towards more sophisticated infrastructure, with an ever-increasing population, so will the demand for safe, reliable electric energy. Not only will the heavier demands placed on our distribution network require equipment to work more efficiently, but it must do so in a safe manner with the least impact to our environment. When we look at the demands our modern world has bestowed upon us as it relates to the transformers we use in our electrical distribution networks, JST is the supplier with the right product, safe, reliable, and efficient cast resin transformers, supplied the right way, with the least environmental impact to meet our modern-day demands. As electric power distribution becomes closer to where we live and work, JST is in the best position to deliver better products, enabling us to maintain a better environment while supplying the most value for their customers and benefits to those for which the products serve. At the end of the day, JST provides the transformers which are designed for value, engineered for quality, and built to last.